Okay. Students, then you know what are the steps to draw the BOD plot. Okay. That steps you should be strictly followed for any transfer function. You can easily draw the BOD plot, and within a fraction of seconds you can easily get the answer. Okay. So first I want to do it. Now this is the transfer function whatever we are considering. First we will finish the BOD plot for this particular transfer function, and after that I will try to analyze how to get the answer in a fastest way without doing that steps also I will tell you. Okay. Right. Now first we will try to draw the BOD magnitude plot. Magnitude in terms of dB. Magnitude in terms of dB versus frequency. Magnitude in terms of dB. This is actually logarithmic omega. Okay. Even if I write omega, but any calculations part involved, this is not omega, this is log omega, because this is semi-log sheet. Okay. Right. Now what is the starting magnitude? You already calculated the starting magnitude is a formula, and you are calculated what is the starting magnitude for this particular problem. Then the starting magnitude for this particular problem you are getting as plus 60 dB. Is it right or not? Now the starting magnitude is plus 60 dB. Now what is the starting slope? The starting slope is decided by slope of number of poles at origin or slope of number of zeros at origin. In this transfer function there are 2 poles at origin. Therefore the slope is 2 into minus 20 minus 40 dB per decay. Therefore this is minus 40 dB per decay. Minus 40 dB per decay. Okay. Actually I missed one step. The last step is, I think around step 6 you are writing, right? Now one more step. Okay, this is the important step. Now write. So I missed this. Okay, I forgot this. You just take it. Now this step 7 is write the corner frequencies. Write the corner frequencies in the ascending order. Write the corner frequencies in the ascending order on the frequency scale. First we want to do that. Okay. Write the corner frequencies in the ascending order on the frequency scale. Okay. Now first you want to do this. Okay. Write the corner frequencies in the ascending order on the frequency scale. This is the frequency scale. First you write the corner frequency in the ascending order. What is the first corner frequency? 1 radians, ascending order. Next root 10. Next 10. These are the corner frequencies in ascending order. Next, starting magnitude is 60. Starting magnitude is 60 dB. Starting slope is decided by slope of number of poles at origin or slope of number of zeros at origin. Now this minus 40 dB per decay, it should be continue up to the first corner frequency. What is the first corner frequency? The first corner frequency is 1 radians per second. Now this is the corner frequency. This will be continue for 1 radians per second. Then you go to 1 radians per second. Now where is 1 radians per second? This is 1 radians per second. At 1 radians per second, two simple poles. At 1 radians per second, two simple poles, right? Or two simple poles are two finite poles. Now two simple poles or two finite poles produce a slope of 2 into minus 20. 2 into minus 20 means how much? Minus 40. So that minus 40 you should be taking and added to the previous slope. Now at 1 radians per second, two poles, two simple poles, 2 into minus 20 minus 40. Now that minus 40 you have to consider and add to previously. So now minus 40 minus 40. Now it will become minus 80 dB per decay. Now the slope is minus 80 dB per decay. Now the students are asking one question, sir, why you should add only at 1 radians per second? Now that what is the answer? What is your answer? Sir, why you should add this minus 40 to this and only at this? Why you are not adding at 0.5? Why you are not adding at 0 radians per second? Because what is the definition of corner frequency? Corner frequency is the frequency. The slope is changes from one level to another level. Minus 40 will become minus 80. Minus 80 will become minus 100. One level is changing to another level only at a particular frequency. That particular frequency is called as corner frequency. Understand or not? Yes. Now this is minus 80 dB per decay. Now this is up to the next corner frequency. Now this minus 80 dB per decay is up to the next corner frequency. Now the next corner frequency is root 10 radians per second. Now at root 10 radians per second, 2, what is that? At root 10 radians per second, again 2 poles, again 2 simple poles or 2 finite poles. Now 2 simple poles or 2 finite poles produce a slope of 2 into minus 20, which means again minus 40. Again take that minus 40 and add it to the previous one. Now minus 40 and minus 80, now it will become minus 120 dB per decay. Minus 120 dB per decay. Now this is up to the next corner frequency. What is the next corner frequency? The next corner frequency is 10 radians per second. The next corner frequency is 10 radians per second. Now, the next corner frequency is 10 radians per second. Again, go same procedure. Go to 10 radians per second. Yes. Now, at 10 radians per second, one simple pole. One simple pole. See, remember the word simple pole or simple zero, which is having some corner frequency. Now, at 10 radians per second, one simple zero produces a slope of plus 20, right? Plus 20. And take that plus 20 and add it to here. Plus 20 minus 100, now it will become minus 100 dB per decay. Right? Now this is minus 100 dB per decay. Now the question is, this is the BOD plot for a given transfer function, which is very simple. And one more thing also you have to remember or not, this is very simple. You can easily understand minus 100 dB per decay is the final slope while I am drawing the BOD plot, but previously you already calculated. Previously you are calculating the steps around, I think step 6 or step 7, what should be the final slope. You already calculated the final slope is NP minus NZ multiplied with minus 20, and you can get minus 100 dB per decay. And after drawing the BOD plot, now your final slope is also minus 100 dB per decay, which is matching or not, which is correct or not. Yes. Now you can easily identify. Now let us ask one question, one simple question. The same problem. Which of the question is the given transfer function? Which of the following is the correct BOD plot? Now students, now which of the following is the correct BOD plot for the given transfer function? There are 4 options. In a 4 options, there are 4 BOD plots. Now how you can approach? What is your approach? So can you go for step 1, step 2, step 3, step 4, step 6 like that? The step 7 or step 8? Then you should be follow these steps. So it will take a 1 hour time. But in a GATE examination, now 1 minute or maximum 2 minutes for each and every question. So how you are approach? Now how you can easily get the answer? So for that I just tell you one point. While looking the transfer function, you can easily find the final slope or not. What is the final slope? NP minus NZ multiplied with minus 20. Already you are calculating for this particular transfer function, you are getting minus 100 dB per decay, and immediately see the 4 options. Definitely in one of the 4 options, it should not be minus 100, then you eliminate that option. Am I right or not? Is it correct or not? If you are lucky in only one option, final slope is minus 100, then you don't touch anything, you go for directly that particular option. Understand or not? Right? Then students are asking, students are smart, therefore they are asking, sir, in all 4 options, final slope will be same. I cannot eliminate any one of the options. We should be follow the strictly rules and regulations of a BOD plot. No, there may be one more chance. What is the starting magnitude? The starting magnitude is decided by whom? The starting magnitude is decided by number of poles at origin or number of zeros at origin. Is it right or not? Yes. The starting slope is nothing but number of poles at origin or number of zeros at origin. The starting slope is minus 40 means 2 poles at origin. The starting slope is minus 20 means 1 pole at origin. The starting slope is plus 20 means 1 0 at origin. The starting slope is plus 60 means 3 zeros at origin. Like that you can easily guess. See the 4 options. The starting slope is minus 40 and what should be the poles in our transfer function at origin? Oh, 2 poles at origin. That is the reason why the starting slope is minus 40 dB. So in which option the starting slope is minus 40 dB per decay is not there, that option is the wrong option. Therefore you have one more scopes to eliminate the option, one more chance to eliminate the option. Like that, these 2 options are also very useful and at least you should be eliminated one option. Now the students are very smart. They are saying that no sir, the first slope means the starting slope and the ending slope should be same for all the 4 options sir. So how should I eliminate any one of the 4 options? The students are asking a question like this. Sir, starting slope, ending slope are same for all the 4 options. So how I can eliminate sir? No, not a issue, not a problem. Now you first note down this and I will tell you how to get the answer without drawing the BOD plot for this particular question. That's what I am taking n number of possibilities on this particular question such that the remaining questions are very easy for you to solve. Okay. Now you first note down this and after that I will try to get it, which is a very fastly how to get the answer without doing all these steps. Okay. First you take this one. And this is the last step. Okay. Write the corner frequencies in the ascending order on the frequency scale in our step list. But while come to the practical view, so while drawing the BOD plot, that should be first you have to be drawn. Okay. Write the frequency scale and indicate the corner frequencies in the ascending order. And after that you start step 1, step 2, step 3 like that. Okay. Then you first take the note down this. Okay. Okay, don't worry. Then I will make very simple. Now see this transfer function. Okay. From this transfer function, now we'll take solve a few problems from the transfer function. Okay. Now you don't forget, you don't see this BOD plot, see only the transfer function. Now my question is, I take one question. Question number 1, let us take question number 1. Find slope of the line. Find slope of the line between the corner frequencies, between the corner frequencies. Find slope of the line between the corner frequencies 1 to root 10 radians per second. Find slope of the line between the corner frequencies 1 to root 10 radians per second. Find slope of the line between the corner frequencies 1 to root 10 radians per second. Now, this is 1 to root 10 radians per second. Now I am asking one question. Find slope of the line between the corner frequencies 1 to root 10 radians per second. Now in between these two frequencies, now what is the highest current frequencies? Now 1 and root 10. Root 10 is highest current frequencies. Now here consider all poles, consider all zeros. Okay, I am using the word consider all terms, means all poles, all zeros below root 10 radians per second. 1 radians per second, root 10 radians per second, 10 radians per second. Below root 10 means 1 and no corner frequencies, right? This is no corner frequencies. Now below root 10 radians per second, consider all poles and all zeros. Below root 10 means at 1 radians per second 2 poles, and here at poles at origin again 2 poles at origin. So totally here there are 2, here there are 2. Totally 4 poles. No sir, 2 poles, 3 zeros, or 3 zeros, 4 poles, 6 poles, 5 poles, 6 zeros, 5 zeros, like that, whatever the combination, 4 poles. Now I am asking, what is the slope of each pole? 4 into minus 20, which is nothing but minus 80 dB per decay. Now with the same procedure, can we find the next one? Now I will take another question, question number 2. Find slope of the line, find slope of the line between the corner frequencies, find slope of the line between the corner frequencies, find slope of the line between the corner frequencies root 10 to 10 radians per second. Find slope of the line between the corner frequencies root 10 to 10 radians per second. Okay. Now find the slope of the line between the corner frequency root 10 to 10. Same procedure. Consider all terms less than 10 radians, because which is the highest one? 10. Consider all terms less than. Consider all terms less than 10 radians per second. So if you consider all the terms less than 10 radians per second, less than 10 radians per second means now root 10 is also coming. At root 10 there are 2 poles, at 1 again 2 poles, no 2 poles at origin. Total 6 poles. 6 poles, which is nothing but 6 into minus 20, which is equal to minus 120 dB per decay is the slope. Okay. Now this is the slope of the line. What is the meaning of the slope of the line? So see the students, this is 1, this is root 10, 1 and root 10. If you take 1 and root 10, draw a line, that line slope he is saying minus 80. Similarly, this is root 10 and 10, this is root 10 and 10. Between root 10 to 10, if you draw a line, the slope is minus 120. Sir, this is correct or not? This we can identify from the transfer function. Is it right or student? Now from the transfer function, I can get this value, but you already draw the BOD plot for the same transfer function. How you can get? Now see here, 1 to root 10. If you draw a line 1 to root 10, now here it is minus 80. How much you can get? Minus 80. Is matching or not? Without drawing the BOD plot, just by looking the transfer function. Next, root 10 to 10. Root 10 to 10, if you draw a line, what is the slope? Minus 120. How much you are getting? Minus 120. Now the students are asking the previous question, sir, if starting slope and final slope will be same, I cannot eliminate any one of the 4 options with your shortcut method. Now there is no need of starting slope and ending slope. Now see the students, I know starting slope, I know ending slope. Now I know the slope of the line between any 2 corner frequencies. If you give any 2 corner frequencies, I can find the slope. If you give any 2 corner frequencies, I can find the slope. If the transfer function is available, then you tell me the students, is there any need to draw the BOD plot with all the 7 or 8 steps I am saying? Not required. Starting magnitude you know, starting slope you know, ending slope you know, slope of the line you know, then what is the necessity of drawing the BOD plot with the rules and regulation, all these things? No, use this shortcut method and use this procedure now, which is useful to get the answer within a fastest time. Understand or not? Slope of the line, you can find the slope of the line between any two frequencies with the same procedure. Okay. Now you just take this shortcut method and you can see this one and that one is correct or not. Okay. Note down this. Okay. Now I'll take another question. Find slopes around the corner frequency. Find slopes around the corner frequency of 1 radians per second. And again one more question. Find slopes around the corner frequency of root 10 radians per second. Now this is one question. Now for this question the procedure is, from the transfer function I want to explain this. Okay, you should remember that point also. Now first you want to consider less than 1 radians per second. Consider means all poles and all zeros. Okay, now that is fixed. Consider all the poles and zeros less than 1 radians per second. Less than 1 radians per second means here only 2 poles at origin, whatever it may be. Okay. Now now you consider less than or equal to 1 radians per second. Less than or equal to 1 radians per second. Now less than or equal to 1 radians per second means, less than 1 radians per second is this. Less than or equal to 1 radians per second means, now here 2, here 2, total 4. Zeros are poles only. If it is zeros, write zeros. If it is poles, write poles. If 2 zeros, 3 poles, like that, whatever it may be. Okay. Now find the slopes. Now which is nothing but 2 into minus 20, which is nothing but minus 40 dB per decay, and 4 poles, which is nothing but 4 into minus 20, which is nothing but minus 80 dB per decay. Now the slopes around the corner frequency of 1 radians per second, minus 40 to minus 80. Now see, check here. What are the slopes around this 1 radians per second? Now around this 1 radians per second, the slope is, around this 1 radians per second, the slope is, now this is minus 40, this is minus 80. Okay. The slopes around 1 radians per second. Now in and around 1 radians per second, minus 40, minus 80. What you are getting? Minus 40, minus 80. Is matching or not? Now this is the slopes around 1 radians per second. Now similarly you find for this slopes around the corner frequency of root 10 radians per second. The slopes around the corner frequency of root 10 radians per second means the same procedure. First, less than root 10 radians per second, and next less than or equal to root 10 radians per second. Less than root 10 radians per second and less than or equal to root 10 radians per second. Less than root 10 means 4 poles. Less than or equal to root 10 radians per second means 6 poles. Now 4 poles is nothing but 4 into minus 20. 6 poles is nothing but 6 into minus 20. Therefore, this is minus 80 dB per decay. Now this is minus 120 dB per decay. Minus 80 dB per decay, and this is minus 120 dB per decay. Now this is slopes around the corner frequency of root 10 radians per second, minus 80 to minus 120. Understand not? Minus 80 dB per decay to minus 120 dB per decay. Now slopes around the corner frequency of root 10. Now you see here at root 10, in and around root 10, minus 80, minus 120, minus 80, minus 120. Is matching or not? Like that you can easily get the answer. Now students are asking, sir, why you want to do this one? If you draw the BOD plot, then the answers are very simple. Why again these steps and all these things are remembered? Now one big question is there. The transfer function which consisting of 10 poles and 10 zeros. In such a situation, slopes around the corner frequency means you do all the steps and you draw the BOD plot. It will take more time for getting 1 mark. But if these shortcuts are available, if this is the question directly, then there is no need of drawing the BOD plot. You go for this approach and you can get the answer very easily. Okay, note down. This is another way to judge that the given transfer function and the BOD plot is correct or not. You can easily identify. Okay. Now I'll write one more question. Find change in slope at a corner frequency of 1 radians per second. Find change in slope at a corner frequency of 1 radians per second. Find change in slope at a corner frequency of root 10 radians per second. Find change in slope at a corner frequency of root 10 radians per second. Okay. Find change in slope at a corner frequency of 1 radians per second. Find change in slope at a corner frequency of root 10 radians per second is question. So if you want find change in slope at 1 radians per second, go to 1 radians per second and measure the slope. At 1 radians per second, what is the slope? 2 simple poles, because corner frequency means definitely poles are zeros. 2 simple poles, which is nothing but 2 into minus 20, which is nothing but minus 40 dB per decay. Again, change in slope at root 10 radians per second, go to root 10 radians per second, measure the slopes. Again at root 10 radians per second, 2 simple poles or 2 finite poles. 2 simple poles or 2 finite poles is nothing but 2 into minus 20, which is nothing but minus 40 dB per decay. Now, if you want a change in slope at 10 radians per second, at 10 radians per second, now one simple 0, 1 into plus 20 dB per decay. Sir, what is this? What is this means? Change in slope at, see here, change in slope at 1 radians per second, minus 40 will become minus 80. What is the change in slope at 1 radians per second? At 1 radians per second, change in slope is minus 40 dB per decay. Is correct or not? Next, at root 10 radians per second, what is the change in slope? At root 10 radians per second, minus 80 will become minus 120. Now the change in slope is minus 40. What is the change in slope at root 10 radians per second? Is minus 40. Now the question is, at 10 radians per second, what is the change in slope? Minus 120 will become minus 100, means minus 120 plus 100. Sorry, minus 120 plus 20 is minus 100. Now, at 10, change in slope is plus 20. Then you tell me in the shortcut method, at 10 radians per second, what is the change in slope? At 10 radians per second, one simple 0, 1 into plus 20. So, plus 20 dB per decay is the change in slope. Is a shortcut method. You can get the answer directly or not without drawing the BOD flat. If this itself is the question, what is the change in slope? Use this shortcut method, you can get. Now you tell me, students, what is the change in slope formula? The change in slope at any particular frequency. The change in slope at any particular frequency is nothing but slope of number of simple poles or slope of number of simple zeros at that particular corner frequency. Go to that particular corner frequency and measure the slope of that particular simple poles or measure the slope of that particular simple zeros, then it should be the change in slope at that particular corner frequency. The change in slope at any particular corner frequency is nothing but slope of number of simple zeros or slope of number of simple poles at that particular corner frequency. Go to that particular corner frequency and find the slope of number of simple zeros or find the slope of number of simple zeros will give the change in slope. Okay, note down this. Clear now? These are the shortcut methods you can get directly without drawing the BOD flat. Now this is the given transfer function g of s, which is equal to 10q into s plus 10 by s square into s plus 1 whole square into s square plus s plus 10. So I hope you understand now how to get the BOD flat without doing all these things. Okay. Now I will take one problem and now use all these shortcut methods and tell me what are the answers directly. Now this is the transfer function which is given to you, g of s, which is equal to g of s, which is equal to 1 plus s by 2, 1 plus s by 20, 1 plus s by 100, 1 plus s by 500. Now this is sq. Now these are the powers which is given. This is the transfer function which is given to you. Okay, this is the transfer function which is given to you, and what he is asking is he is asking three questions. Now you tell me without drawing the Bode plot, within a fraction of seconds you want to tell me the answer. Now the questions are change in he is asking slope of the line between 2 to 10. Slope of the line. This is one question he is asking. Slope of the line, where he is asking slope of the line between 2 to 10. Slope of the line between 2 to 10 radians per second. Slope of the line between 2 to 10 radians per second. Now between 2 to 10, highest is this. Now consider all the terms less than 10. Less than 10 means less than 10. All are in time constant form. Less than 10 means now here less than 10 means here 5 zeros and 3 poles, right? Now this is nothing but 5 zeros and 3 poles. So I am already saying that if zeros are more, zeros minus poles. If poles are more, poles minus zeros. Therefore, now zeros are more here. Therefore, NZ minus NP multiplied with zeros are more multiplied with plus 20, which is nothing but plus 20 dB per decay, which is nothing but zeros are 5, poles are 3, 5 minus 3 into plus 20 dB per decay, which is nothing but 5 minus 3, 2 into plus 20, so plus 40 dB per decay. Now this is the slope of the line between 2 to 10. Now you take one more thing. What is the slope of the line between 10 to slope of the line between like 10 to 20? You write one more question, 10 to 20. Slope of the line between 10 to 20 radians per second means consider all the terms less than 20 radians per second. Less than 20 means now 6 poles, 5 zeros. 6 poles and 5 zeros. 6 poles and 5 zeros. Now 6 poles is nothing but 6 poles NP minus NZ. Now poles are dominating, therefore minus 20 dB per decay. So 6 minus 5 multiplied with minus 20 dB per decay, therefore which is nothing but minus 20 dB per decay is the slope of the line. Okay, this is one question like that. This is the question for slope of the line. Next, slopes around the corner frequency. Slopes around the corner frequency. This is another question you can write. You can form n number of questions for the given transfer function. Slopes around the corner frequencies. Now slopes around the corner frequency of, let us take 2 radians per second. Now what is the slopes around 2 radians per second? Now what is the formula? Go to that particular slope and go to that particular corner frequency and find the slope. At 2 radians per second, 5 simple poles. At 2 radians per second, 5 simple poles. Therefore, 5 into minus 20, which is nothing but minus 100 dB per decade directly. Right. Next, at 10 radians per second, what is the slopes? Sorry, this is change in slope, right? Sorry, this is change in slope. Change in slope at a corner frequency of at a corner frequency of, change in slope at any corner frequency is nothing but slope of number of simple poles or slope of number of simple zeros at that particular corner frequency. Now see the question. Change in slope at a corner frequency of 10 radians per second means go to 10 radians per second and find the slope at that particular corner frequency. At 10 radians per second, see at 2 radians per second, this is 5 simple zeros. Numerator, no? 5 simple zeros. So 5 into plus 20 is plus 100 dB by decay. Now at 10 radians per second, 3 simple poles. 3 simple poles. 3 simple poles is nothing but 3 into minus 20, which is nothing but minus 60 dB per decay. Minus 60 dB per decay. This is a change in slope at any corner frequency. You can easily measure. Now the question, one more thing. Slopes around corner frequencies. That is your question, right? Now slopes around the corner frequencies. So now I am not drawing the BOD plot. I will tell you the answers directly. Slopes around the corner frequency of. Now you will check slopes around the corner frequency of 2 radians per second. I am giving one procedure. Now first consider less than 2 radians per second. Consider all the terms less than 2 radians per second. Next, less than or equal to 2 radians per second. This is the procedure I am giving to find slopes around the corner frequency. Less than 2 radians per second means only 3 poles. Less than or equal to 2 radians per second means 5 zeros, 3 poles. 5 zeros and 3 poles. So 3 poles means not a issue. 3 into minus 20 is nothing but minus 60 dB per decay. And 5 zeros, 3 poles. Who is dominating? 0 is dominating. 5 minus 3 multiplied with, now 5 minus 3 multiplied with, zeros are more, poles are less. 5 minus 3, zeros is nothing but plus 20. Means 5 minus 3, 2 into 20 plus 40 dB per decay. Now this is minus 60 dB per decay. Minus 60 dB per decay to plus 40 dB per decay is the slopes around the corner frequency. Now, slopes around the corner frequency of 10 radians per second. Same. First, less than 10 radians per second and less than or equal to 10 radians per second. Consider all the terms less than 10 radians per second and less than or equal to 10 radians per second. Less than 10 radians per second is nothing but 5 zeros, 3 poles multiplied with plus 20. 2 less than or equal to 10 radians per second means less than or equal to 6 poles, 5 zeros. Therefore, 6 poles, 5 zeros multiplied with pole means minus 20. So 2 into 20, 40 dB per decay. Now 6 minus 5, 1 into minus 20, minus 20 dB per decay. Okay. Now this is very simple. Okay. You just take everything for any problem without drawing the BOD plot. This is the procedure you can do it.